Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
I noticed in the charge that's on the Tumblr site from the introduction from, I guess, yesterday, that the ultimate challenge of the conference is to find a way of doing research so that 15-year-olds could do this. I have enough problems with PhD students taking my ideas and being better than me, so I'm not quite sure why we want to do this. But let's take it as a good. What I want to tell you about very briefly is a collection of projects that already involve 6-year-olds in actually producing research. Also some 80-year-olds and everything in between, which is our Zooniverse collection of citizen science projects. This will be half talk, half demo. I think the critical thing here is that what we're trying to do in a whole range of fields is find a really easy entry point to doing something meaningful. So if you can find something that can be done in a web browser without any training, then that becomes the gateway drug that encourages people to go on and do more advanced things. And so this is sort of the lower level of what could be a career progression for people, whether professionals or non-professionals, to contributing to research. So the original example of this was a project called Galaxy Zoo, which was knocked up because PhD students will only classify 50,000 galaxies before telling you where to stick the rest of them. And we were just getting classifications by shape. And so it's a simple web app, in this case 6 buttons, say what you see. And not only did the classifications turn out to be better than professional astronomers, classic wisdom of crowds, crowdsourcing, so on. Galaxy Zoos had something like 250 million classifications in 4 years from about 250,000 people. But also you get the inherent advantages of humans looking at your data, which means that not only do they do the routine task of classification that you've taught them to do, but you make serendipitous discoveries like this one. This is Hanny's voorwerp, which loosely translates from Dutch as Hanny's thing, which is a beautiful, unique astronomical object that's important enough that we get Hubble Space Telescope time to look at it. But we realized pretty quickly that although we'd built a system for classifying images of galaxies and assigning labels based on the shape, that if you looked at this as a programmer and abstract this away, then you have a very general model. So any of our projects models something like this. So you've got a volunteer who we try not to call a user, but I keep slipping. A volunteer, somebody who's come to the website, and their task is to take part in a project, which might have multiple tasks. You might have different things you ask them to do. And essentially, you're annotating an asset. And that asset could be an image, but it could be a sound file. We've got video projects. It could be a simulation that's running on their laptop. It could be absolutely anything. And you could go even further. And we quickly realized that as my phone kept ringing, and as people started wanting to do these projects themselves, we can even abstract away. And so I'm slightly pleased I'm the first person to show code this morning. But this is a domain-specific language written on the back of Ruby for creating Galaxy Zoo and projects like it. And the point is that we realized that, at least in my world, scientists are quite happy to learn the 20 commands that allow them to do LaTeX badly. And so we're trying to create a language with 20 or so commands for specific types of these projects so that people can play around and try and create their own, either for use within their own research group or to play with us. So let me just go to the web browser. I'll show you a couple of examples. Is that going to resize if I do that? No, probably not. Okay, this is the current Zooniverse home. So we've got 10 projects live currently, another 24 coming in the next couple of years, thanks to Josh and Sloan, who are funding it. Most of them astronomical, just because of where we started. So Galaxy Zoo's there. But also, I'm not going to have time to talk about this one, but if you want to spend the rest of the day classifying papyri and reading texts that have been lost for 2,000 years, that's ancientlives.org. But just to give you an idea of the scope of this, we have old weather. Each of the projects off that main page has a splash page, but if we go in, old weather is trying to help climate science by rescuing weather data from old Royal Naval ship's logs. And so this is a tool for recording very specific weather information. And you can see this is, this is a handwriting recognition task, but we have some temperatures in here, and we have some codes that tell us about the wind speed. So that's southwest. Let's say that's southwest. Yeah, and that then produces a weather report that could go into an international archive of historical data. And you also have all sorts of fun family history and things that come up as well. This tool, by the way, this transcription tool has been completely generalized and open sourced. And so I know we've got some humanities people, although we've heard mostly from scientists. And so there's a generalized transcription tool available on GitHub. It's Zooniverse/scribe. You can also, of course, you get here too, you get the serendipitous discoveries. My favorite piece of research from old weather is this. This is an example. This is from HMS Africa. For those who can't see the dates here, at 1917 to the end of 1918. And this is the number of the crew who were on the sick list as recorded in the ship's logs. We didn't ask people to record these. People just wrote these down when they saw them. We can then mine the database. The crew, there are about 600 people on board ship, and almost 500 of them are sick, and this is of course, the Spanish flu outbreak. And this is an isolated community. We know where the ship was last, and we know this for all the ships, and so we now have epidemiologists who are happily looking at this stuff. One of the things that we've discovered in the last year that I think is really interesting is that it's not just visual data that people are interested in. If you give people the right incentive, and you can talk to them about why you need their help, they're interested in mining data that doesn't look particularly interesting either. This is a screenshot from a site called Planethunters, which is another one of ours. This is data from the Kepler Space Telescope, and you're looking at the brightness of a star over time, recorded every 29 minutes. Each dot is a measurement. And hopefully it's just about visible, but here, here, and here, there are periodic dips in the brightness. This is where something has got in front of the star. And in fact, this is the signature of a planet that's orbiting this star. Now, Kepler have an automated routine that's picked up about 2,000 very good signals like this, but we're finding the ones that are dropping through the cracks and then passing. So this in fact, was a discovery by one of our volunteers, a guy in Latvia who won't answer his email. So I've no idea who he is or anything about him other than that he wants registered. And so we're providing a safety check and a tool for learning that can go back to the machine learning people who are trying to mine this data automatically. For those of you who heard a few weeks ago, months ago now, of the first discovery of a planet orbiting a double star, we had an independent discovery of this 2 weeks after the other team had found it internally. So we were just behind the professionals at finding these unusual systems. But we have another 4 of them that we think look promising. And so there's this really interesting space in which the automated routines are getting most of what's there, but for the unusual and the weird, you really need people. Now, I started by talking about these things as a gateway to more advanced interfaces and behavior. And one of the things we tried, this is Planet Hunter's homepage, one of the things we tried really hard to do is in the classification routine, I'm just checking I'm not discovering a planet on stage. No, there's nothing there. You always get this question, which is, would you like to discuss this star? If you click yes, you go into our talk environment, which is sort of object-orientated discussion. So there's a chance to make a really quick comment on this thing or to start a discussion about it. This is enabled with Twitter-style hashtags and all the rest of it. So you might as well start one. Seen live at MSR Research. And so the point here was that we were getting a lot of science and a lot of discoveries out of the Galaxy Zoo the forums, but they were very hard to mine. The forums got a couple of 100,000 posts, whereas here we can quickly see discussion building up amongst users. This is unusual, what is it? Then this other user comes in and says, well, look, I've pulled this other data and I've done this analysis, and I think it's interesting. And so we're getting an automatic email to the science teams of discussions that look interesting. And then we can put the professionals in touch with those amateurs who have worked their way up the system and started doing really interesting things. The talk code, by the way, is also open source and available. And all I'm going to say finally is that what we're working on now, which will go live next year, is a sort of live version of this. We already have this with a supernova hunting project that takes data live off a telescope, analyzes it within 10 minutes. We're going to try and put machines into that loop as well, so that on the fly we can make a decision about whether to pass a classification to a machine or a human. And if you want to hear more about that, then you'll have to come and find me later on.